Hi everyone, welcome to my Tech Talk. Today I'll be talking about enhancing service availability in power interrupted environments using k0s and Tailscale. Before we start, let me just introduce myself. I am Justine Che Romero and I lead the development team at Demograpo. I'm passionate about solving unique problems and essentially finding creative ways to solve them. So you can connect with me at JustPeaceBus at X or Twitter, or you can follow my projects at GitHub. This talk will be divided into three parts. On the first part, I'll be talking about our background, the challenges we face, and establish our scenario that justifies the need for Kubernetes. Next, I'll show you the tools that we're using, essentially basic overview of k0s and Tailscale. On the third part, I'll give you some walkthrough on how to set up Kubernetes using the tools mentioned, where I'll discuss the network setup for the nodes, the bootstrapping process, and the required config to make k0s and Tailscale compatible. So I'll end this talk with a live demo on setting up a minimal Kubernetes cluster so that you can see each step in real time. Okay, so let's start with our story. Essentially, we're a company based in the Philippines that helps organizations to operate efficiently and effectively using the latest technology and data science. So on the picture on the top shows our CEO orienting a youth leadership summit for an organization. Meanwhile, at the bottom, he's presenting to the Center for Policy and Executive Development on how to democratize access to geographic or geospatial systems using AI and data science. So from these instances, you can see that we're working on variety of projects within a wide range of domains. Each project entails different client needs, and most of them is the preference for hosting servers locally near them. However, self-hosting in a developing country, such as the Philippines, does not come without challenges. The most disruptive of them are the frequent power interruptions and the typhoons and natural calamities, which are expected to hit us every season. So, for instance, the image on the top shows the scheduled power interruption announcement. If you could zoom in closely, you can see that it lasts from 8 a.m. to 5 p.m. in the afternoon, which is essentially the whole working hours. So, if a server is affected there, we can expect that no productive output can be done for the whole day. Just imagine it happening regularly. You're probably thinking that the simplest solution for this is just to host everything on the cloud. Well, it's a bit complicated. Some services work well on the cloud, so we put them there, but other projects have their own unique needs. For example, organizations hold highly sensitive data about their constituents, such as the socioeconomic status, the beneficiaries, and others, which is too much of a risk of putting them into the cloud instead of just storing them locally in a server near them. So another scenario is when we're processing large amounts of geographic data. It's a bit obvious here that the cloud GPU consumption alone would cost us a lot of money instead of just buying one dedicated hardware and then use them indefinitely without worrying about the cloud bills. So yeah, cloud hosting alone will not solve most of our problems. So just to give you a summary of our scenario, we have full control and ownership of nodes distributed across the country. Our goal is to achieve fault-tolerant services with minimal downtimes, ideally less than 1 minute, with 5 to 10 minutes being acceptable. Also, data redundancy and high availability are essential requirements. So from those points, I hope it's not unclear to see why Kubernetes is a good fit for our setup. Kubernetes has its own complexities. Most shy away at self-hosting it because it's a bit complex to configure from scratch. By default, Kubernetes assumes that the nodes should be able to communicate with each other within a locally connected network, which in our case, they are all geographically isolated. And cluster bootstrapping have many moving parts and hard to get right. Fortunately, like all complex problems, it definitely helps to use the right tools for the job. So here in the second part, I'll talk about those tools and give you some overview on what's their function and capabilities in self-hosting Kubernetes. Let's start with our Kubernetes distro. For those who don't know, a Kubernetes distribution is a pre-built or pre-packaged software with Kubernetes inside of it. For this cluster, we choose k0s as our primary distribution because of its simplicity and relatively low barrier of entry. Like it's well documented and you can easily start with just one or two CLI commands. It also ships with a single binary, setup is very easy, and resource usage is relatively low compared with other distros in the market. As I mentioned before, Kubernetes assumes that the nodes are directly connected to a local network. But since our servers are all geographically isolated, we need a way to essentially virtualize our network. So the best tool we've found for this is Tailscale, which is basically a layer 4 VPN. Traffic communications are encrypted and secured since they're using WireGuard under the hood. Plus, I can essentially restrict or direct the network topology of the nodes via ACLs. So by default, Tailscale clients tries to connect to the servers directly via P2P. But if there's no direct connection, a derp server is utilized as a fallback. Now, since the tools needed for our setup has been established, let's now talk about how we'll combine them together to create our Kubernetes cluster. Our first goal to bootstrap our cluster is to connect every server via Tailscale. We can do this by adding each node to our Tailscale network. And first, of course, we need to sign up for an account at tailscale.com. Next, add each machine to our dashboard. Every time you add a machine, Tailscale will prepare a terminal command that you can just copy paste to your machine. This command will essentially install Tailscale client, and once you start it up, it will prompt you to log in. Well, it's straightforward. Just follow instructions prompted by Tailscale, and you're good to go. So to verify that the server now belongs to the Tailscale network, you can check if there's a new network interface present named Tailscale 0. Note that for our Kubernetes setup, we want the traffic to go to this interface instead of the default host network interface. Once verified and the nodes are connected to each other, we can now proceed to bootstrapping our cluster. To make our bootstrapping process easier, we're going to use a tool called k0s SCTL. k0s SCTL will allow us to declaratively define cluster setup instead of individually configuring and exchanging tokens between nodes. So the process here is illustrated by this diagram. k0s SCTL will use a YAML file containing the configuration for our cluster, and it will do the heavy lifting for us to organize and bootstrap the entire cluster. Essentially, the process is enumerated here. We install first k0s SCTL, we generate a YAML cluster config, and we deploy the cluster. So this is our usual kubeconfig file that we'll be using for our day-to-day Kubernetes interaction. Suppose you did everything right without additional configuration. You connect every node via Tailscale, you bootstrap the cluster using k0s SCTL. Eventually, you'll run into some hefty errors. This is because the default config for both Tailscale and k0s are incompatible. The primary compatibility issue lies within the container network interface or CNI being used by the cluster. So by default, kuberouter, the interface, routes the traffic towards the default host interface. But since the nodes are not in the same local network, the traffic should be routed to the Tailscale 0 interface instead. Also, since kuberouter has no options to specify which host interface to use, we have no choice but to use another CNI. Thankfully, k0s provides another built-in CNI, so we don't have to manually install them. So we just need to change the cluster config YAML a bit. That built-in CNI is called Calico. It has options on what host network interface to use, so we can specify that in the config. And after that, Calico will route the traffic to the Tailscale interface, thereby allowing the nodes to communicate with each other. So the actual config, I'll be presenting it in the demonstration later. So you can just copy paste. Once this is solved, we can now generate the kubeconfig file and use it to interact with our functioning Kubernetes cluster. So that's the basic overview. Let's now get hands-on and try to bootstrap a minimal Kubernetes cluster using k0s and Tailscale. Our minimal setup in this demo will consist of three machines. One is the client, named server 0. This is where we'll be running the bootstrapping commands and we'll be running kubectl to interact with the cluster. The second one is demo 1 machine, which will act as both Kubernetes controller and worker. And lastly, demo 2 is our worker node. So let me just open my terminal. As you can see, we have three terminal open. One is for our server 0, another one's for demo 1, and for demo 2. First thing we'll need to do is to connect each node to each other using Tailscale. So let's navigate to the Tailscale dashboard and add each node to the network by just adding a device here. Select client device and you choose which operating system you're using. So right now, these machines are running Ubuntu, which is Linux. I'll just copy this here, and same for other networks. Same for other machines. So essentially now, we'll just wait until Tailscale is installed. So in the first machine, it's already completed. So let's run Tailscale up. And this will prompt an authentication link. Just click it and authenticate your servers. So what will happen is you can see a new server being created here at the Tailscale dashboard. So it's named server 0. Let's try for the remaining two. Okay, and the last one. Okay, so now you can see there are now 3 machines connected to our Tailscale network. Next is we want to make sure that the Tailscale 0 interface is present. So we can just run ifconfig and you can see that Tailscale 0 is present. Now that they're connected, let's prepare the SSH connections between the nodes. This is something that k0s CTL requires later to effectively bootstrap the clients. So you can just revert back to your original SSH config after the bootstrapping. So now we need to create an SSH key and authorize its connection to the remaining machines. So to do that, I'll run SSH keygen. I'm going to name it ID k0s and save it at the SSH folder. So effectively, we have a new key. We need to authorize it at the 2 machines. So let's go to machine 1. We edit the authorized key file. We add the client machine. Okay. So the next thing we'll do is we need to make sure that our user here can run sudo commands without prompting a password so that case your SCTL later can use it without any errors. So as I said earlier, you can just revert it back to the original config after the bootstrapping. So let's run vsudo and allow demo to the demo user to run without password. Okay, so just to quickly check if the passwords are not being prompted. Okay, seems like everything's working. Since the nodes are now connected in a private network, let's now start the process of bootstrapping the cluster. So what we're going to do first is install k0s and k0sctl. So to install k0s, you can just run this command. It's documented in k0s official documentation, so you can just copy paste it there. So we'll just wait for it to download. Okay, so now k0s is to check if k0s is already installed. We can run k0s version. Okay, k0s is installed. Let's now install k0sctl. So as usual, this is the installation commands are present in the documentation. So just copy paste them. So now we have a k0sctl binary here. We give it permission to execute. So let me just organize this a bit and move it inside a folder named bin. Okay. And we want the bin folder to be inside our path environment variable. So let's add it. I think I already add it here, but in your setup, if it's not already present, you can just add the new path there. And we run source bash rc. Okay, to check if k0sctl can indeed execute, we can run k0sctl and check its version. So it's running. And now that we installed it, Now, let's proceed to declaring the cluster inside the YAML file. We can generate a template YAML config by using k0s Tailscale. So we'll run that by using k0s Tailscale init, and it will generate a config.yaml. Let's inspect the file to see its content. Um, you can see that this file contains all the configuration of the cluster. Here, we're going to declare our hosts, the interface we need, and the additional settings to make Tailscale work with k0s. Let's start by first updating the hosts to match our Tailscale network. So in our case, the first host is located at demo 1. The user is demo. Port is 22, and key path is in IDK0s. Okay. So for this example, the first node will be both a controller and a worker. And let's set up the next node. Another thing is we need to specify the private interface where the workcase here SCTL will use the bootstrapping process. So you can see we're just using one word host name instead of the full subdomain with TLD. This is a nice feature by Tailscale Magic DNS. Also here, we specify the private interface to be used while bootstrapping, which should be Tailscale 0. Next thing we're going to do is set the IP addresses of the Kubernetes API server. Since we're deploying the controller at demo 1, we can just copy paste it from the Tailscale dashboard and update our YAML file. So the corresponding config will look like this. So the address here, we'll just copy paste from the dashboard. So the controller node would be demo 1. So I'll just copy the IP address for demo 1 and define other alias here. Let's see, demo 1. Lastly, as mentioned earlier, we need to swap out the default container network interface with Calico. So to do that, I prepared the config. We just specify the network provider as Calico. Then we should tell Calico to use Tailscale 0 as its interface. We also need to add some configuration to make Calico compatible with Tailscale, such as the conflicting net filter packet marks and other settings. So overall, this looks like a good config. So let's try to save this and attempt to deploy the cluster. So wait, so to deploy it, we run k0s apply, and we specify the config file that we just created. We just config.yaml, and I'm going to have the debug option here just so that we can see if there's any error in the bootstrapping process. By this time, k0s CTL is doing most of the heavy lifting to connect to each node to the cluster. This includes installing k0s or registering tokens in each of them. So let's just wait for it to finish, and this may take a few minutes. So now that it's finished, let's generate the kube config so that we can use it to interact with the cluster. To generate the kube config file, we're going to run k0ctl kube config and config YAML, and then we put it in a standard directory that Kubernetes could use. So that's kube.kube/config. Okay, so let's try to run some commands to see if our cluster is indeed working. So let's try kubectl. First, we're going to reuse the k0s kubectl. So, but to make things a bit faster, we could just add an alias for kubectl to be the one the one that comes from k0s. So alias kubectl k0s procedure. Okay, and let's check if the nodes are indeed connected. So kubectl get nodes. So as you can see, demo 1 node is ready as well as demo 2. So everything's connected to our cluster. So next is to check the pods. We run kubectl get pods. So you can see everything's working, everything's running. So just to just to check it again, we can deploy a sample deployment. Let's create another deployment called, let's deploy a pod named BusyBox. And essentially what this pod will do is echo hello Kubernetes. So let's save it and deploy this. Let's deploy this. Okay, it's deployed. Let's see if the pods are created. Okay, we can see that our BusyBox deployment is ready and running. Let's inspect if it it indeed does run. So BusyBox deployment here. So it's indeed working by printing help Kubernetes. So nice. Everything seems to be working properly. So I think that's it. We just bootstrap a working Kubernetes cluster from scratch. Just a quick recap. We started by connecting each node to our Tailscale network. Then we declared the cluster config in a YAML file, including the configuration that will make Tailscale and Calico compatible. Then we use k0s CTL to do heavy lifting and deploy the cluster. Finally, we deploy a test pod to ensure that the cluster is working and operational. So hopefully by this time, we can now have an idea on how to self-host or self-manage a Kubernetes cluster from scratch. This could hopefully help you enhance and improve availability of your services, especially if you're in a power interrupted environment such as ours. So thank you everyone for listening and have a good day.